Okay folks, final thing we're going to look at is something called prime decomposition. Okay, now this is something that you're not going to see a huge amount of, okay, but the idea behind it is going to help you with lots of things as you move on in maths in the next few years, okay? So it's something that is just good to have a wee think about. What we're going to do is we're going to look at 6 different examples, okay, 6 different numbers that we're going to do this prime decomposition of, okay? Now the clue is in the title. We're going to have prime numbers in our answer, okay, and decomposition, if leaves decompose or anything decomposes, it's what we term breaking down. So we're breaking it down into something smaller. Here we're breaking these numbers down into smaller numbers that are going to be prime numbers, okay? And the first way to tackle these is to think about 2 numbers that multiply together to give you the number that we've got. Now, we don't want to start with 1 times, okay? So we're looking, if possible, to find something else, okay? To find something else. So, we've got 9, okay, in this first one. So we're going to break that 9 down. Okay, 9 is what times what? Okay, we want something other than 1 times 9. Remember, 1 times 9 wouldn't be the most helpful one here. Okay, so the product, okay, the 2 numbers that will multiply to give me 9 would be 3 and 3. Okay, this is also sometimes called a prime factor tree, okay, because it kind of starts to look like a tree as we do bigger and bigger ones. Okay, now we check the 2 numbers that we've got and we check whether or not they are prime numbers. Now the work that you've been doing, okay, would tell you that these are indeed prime numbers, okay? So the work that you've done up till now, 3, it only has 2 factors, 1 and 3, so our prime decomposition of 9 is that it would be 3 times 3. 18, obviously a slightly bigger number here. Okay, first thing I think of when I think about 18 is that it's 2 times 9. Okay, so I'm going to have 2 and 9 as the start. Now, when we got to that stage last time, the 2 numbers I were left with were both prime numbers, so that was fine. I could stop. Okay, but when I get to that stage this time, 2 is a prime number, so I'm finished. But 9 is not a prime number. 9 has 4 factors, so we can keep going. Remember, we want to decompose this, split it up into prime numbers. So, what is 9? Well, we've already seen from the first example that 9 is 3 times 3. So, the way of writing 18 as a product, as a times sum of only prime numbers, is to write it as 2 times 3 times 3. So all the numbers on this right hand side should be prime numbers. So we're looking for 2, 3, 5, 7, etc. Okay. Obviously, as the numbers get a little bit bigger, it might look a little bit different. Okay, now 17, what have we got? Well, actually, 17 is itself a prime number. So we can't do a prime number tree. We can't have prime decomposition. Okay, so it doesn't, sorry, dodgy writing here. It doesn't have prime decomposition. So just be aware of that. You need to just double check that all the numbers actually are not prime numbers to begin with. Okay, so this one wouldn't prime decompose because it's already a prime number. 17 is a prime number. Whereas 22. 22, we don't want 1 times, remember? We've got 2 times 11. Now, 2 is a prime number. Remember, it's the only even prime number. 11, hopefully in the work you've been doing in the last exercise, you'll have realised 11 is also a prime number, okay? And when you're doing this, folks, I don't mind if you've got kind of your wee exercise that you did before with all the prime numbers circled, or if you look it up on Google, just to help you recognise that which ones are prime and which ones aren't. That might be helpful for you, okay? So, that means that 22 can be written as 2 times 11, and that's nice and straightforward. These are both prime numbers on this right hand side here, so we're done. Now, what about 30? 30 is a bigger number, okay? Where can we start with 30? 30 is 5 times 6, let's go with. You could start with 2 times 15, and I think there's an example in the textbook that does that. Okay, one of the questions in the textbook asks you to start with 2 and 15, but I'm going to start with 5 and 6. Now, 5 is a prime number. Done. Okay. 6, though, is not a prime number, so it needs to decompose further. 6 is 2 times 3. Now, they are both prime numbers, so I'm finished. So my answer is that 30 is 5 times 2 times 3. And remember, you can write these numbers in any order. Absolutely any order. Okay. What about 48? 48 is quite a big number, and some of the work we've done previously, you might remember that 48's got an awful lot of factors, so we could be here for a while. 48, the first multiply sum that jumps into my head that makes 48 is 4 times 12. Okay, 4 12s are 48. That's the first thing I think about. You could start with 2 and 24. You could start with 6 and 8. We're going to get the right answer no matter what we start with, but it'll just look different as we go through this prime factor tree, this prime decomposition. Now, neither of those numbers are prime. 4 and 12, both even, neither of them 2, therefore neither of them are prime. So 4 is 2 times 2. Both of those are prime, so this part of the tree is finished. So we've got 48 is 2 times 2, and then we need to see what the side with the 12 gives us. Okay, so 12 is 6 times 2. Now, 2 is a prime number, so we can stop there, but 6 isn't. So we need to keep going with this 6. You can see why they call these trees, they're kind of upside down trees, because they have all these branches that just keep going. 6, though, is 2 times 3. We've seen that already. And so now we're finished. So to do the prime decomposition, we've got 1, 2, 3, 4 2's. So I need to add a couple more in here. And then we finish off with a 3. Okay. So that is what 48 would be as prime decomposition. Okay, as your prime factor tree. So you've got a little exercise to do on that. Okay, and then the final exercise for the week is just a revision of all the work that we've done in the last few weeks to do with multiples, factors, and prime numbers. As usual, folks, if you want me to go through any more examples, please just let me know and I'll make you up some more wee videos.